See, I am Mr. Dilip Doshi, Assistant Professor, Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. Today we will study about single acting reciprocating pumps. Learning outcomes. At the end of this session, students will be able to understand construction and working of single acting reciprocating pumps. See, first we will classify the pumps. Before that, we will discuss about what for the pumps are required. Pumps are required to lift the water from lower level to higher level, or lower head to higher head. Or sometimes, if you want to pump the water or pump the liquid for a longer distance, so to overcome the frictional resistance losses due to the pipeline casing, inside casing or inside surface, it is to be overcome. Otherwise, the flow will go on reducing and you will not get the discharge of the same quantity. So basically, the pumps are classified as dynamic pressure pumps and positive displacement pumps. So what are dynamic pressure pumps? So in this, sometimes these are also called as automatic. So these are centrifugal pumps, propeller pumps and turbines. Okay. So the centrifugal pumps, in this, the centrifugal pressure or centrifugal forces are utilized to generate a suction, due to which the water will be taken in through suction pipe. Same mechanism or same principle is used for dynamic pressure pumps. Whereas in case of positive displacement pumps, reciprocating pumps and rotary pumps. So in that reciprocating pump, there is a piston pump and diaphragm pump. So in case of piston pump, the mechanism is a piston cylinder arrangement. Suction will be generated during when the piston travels from IDC to ODC, or when piston travels from head to the bottom, the suction will be generated, and due to that low pressure, the water which is at higher pressure, or water will be at the pressure of atmospheric pressure, the water will be taken in by opening the inlet wall, and again during compression, that is when the piston travels from ODC to IDC, the compression will take place, the pressure will be high and the water will be discharged to the overhead tank. So same mechanism in case of diaphragm mechanism also, diaphragm pump also. Another is rotary one. So it is gear type, lobe type, screw type, vane type, rotary plunger type. So all these are given the rotary motion, and in some cases the fluid will be trapped in between these two nearby gear teeth or lobes, and that will be discharged to the higher altitude or higher pressure. So these are some of the classifications which are to be known before studying the different types of the pumps. Now this is a single acting reciprocating pump. So if you observe here there is a piston cylinder arrangement. So this is a piston, this is a piston, this is a cylinder, in which the piston is connected through piston rod to the connecting rod through the crank. So the crank rotates from IDC to ODC during first half, and ODC to IDC during second half. And the crank mechanism, when the crank rotates in the clockwise direction, it will pull the connecting rod, which will pull the piston rod, and that will generate or it will make the piston to move from IDC to ODC, inner dead center to outer dead center. So when the piston is at extreme left, it is called as IDC. When it will be at extreme right, it will be called as ODC. Of course, the piston cylinder arrangement is always, or you should be always, leak proof, so that there will not be any losses of the energy. Now this is a suction pipe, or which contains the suction wall here. This is a suction pipe which contains which has a suction wall at the exit to the piston cylinder, and this is the delivery pipe, okay, which has a delivery wall here. This length is called as a stroke length. Okay. So this length into cross sectional area will be the total volume which will be taken in during suction or sent to the delivery pipe during compression. Now, this is the head, suction head HS, and this is the delivery head HD. So, HS plus HD gives you the total head. Okay. So, lesser the suction head, higher will be the delivery head. Usually the pumps are known by different classifications regarding head or types. So, this is what the total head. So, this total head can't be exceeded than the limit which is given by the manufacturer. So, lower will be the suction head, higher will be the discharge head. So, it should be lesser, so that you can get the discharge at the higher level or higher multi-story building. So, now when let us consider that the crank pin is at IDC, that is sometimes it is also called as at 0 degrees. Okay. When it starts rotating in the clockwise direction, the piston at that time will be at the IDC of the piston, that is IDC of the cylinder, that is at the end of the cylinder or at the head of the cylinder. When it starts moving towards right hand side, the suction or low pressure will be generated in this area. Suction or low pressure will be generated in this area, and due to that the suction valve will be open. The suction valve will be open because the pressure on this water or pressure on this liquid will be atmospheric pressure, whereas the pressure towards left hand side of the piston will be lower than the atmospheric pressure. Due to that, the water will be sucked in to the suction pipe, which will make this valve to open, and the water will enter or will start filling the left hand side area of the piston. Okay, in the cylinder, the water will start filling. When the piston reaches to ODC, that is outer dead center, this is shown as a dotted line. Similarly, here when it reaches from IDC to ODC, that is outer dead center, by 180 degrees, that is first half of the rotation of the crank. So, then the water will be totally filled in the cylinder towards left hand side. So, this area will be full of water or full of liquid. So, during first half there will not be any water discharge through the delivery pipe or delivery pipe. So, only suction will take place or only the water will be taken in the cylinder due to low pressure in the cylinder. Then during next half or second half of the rotation of the crank, that is from ODC to IDC or 180 to 360 degree, there will be compression. So, the piston will start moving towards the left hand side, which will generate high pressure, on the liquid which is towards the left hand side of the piston in the cylinder. Due to that pressure, this suction valve will be closed because there is low pressure, which is the atmospheric pressure on the water in the reservoir, in the sump, and there will be high pressure here. So, the suction valve will be closed and delivery valve will be open. Due to which the water will be discharged through the delivery valve, through the delivery pipe towards the overhead tank. Again I will repeat. So, when the crank rotates from ODC to IDC, there will be compression stroke. Piston will start moving from ODC to IDC, and the pressure will be generated, high pressure will be generated on the liquid present towards left hand side of the piston, due to which suction valve will be closed and delivery valve will be open, and when it reaches the IDC, the total water here will be discharged. So, this is what is length into cross section area, that is the water quantity or water volume which will be discharged through the delivery pipe. So, like that again when it will start second half, that is from IDC to ODC, again there will be suction, and again the delivery valve, suction valve will be opened, delivery valve will be closed, and delivery valve will be closed due to the water column present here, which has a higher load or higher pressure. whereas here there is a low pressure in the piston cylinder arrangement, and the suction valve will be opened. Again the water will be taken in, or liquid will be taken in, and again it will, during compression, it will be discharged. So this is what is the mechanism of the single acting reciprocating pump. So now one question I will ask you: what disadvantage or what problem you observe during for this single acting reciprocating pump regarding discharge of the water? So think over it and tell me. Okay, if you think, you will understand that when the crank is traveling from IDC to ODC, that is first half of the revolution, there is never water discharge through the delivery pipe or delivered through the delivery pipe. So there will always be interrupted supply of water. Only during ODC to IDC, or 180 degree to 360 degree, or during second half of the revolution of the crank, only water will be discharged when there is a compression stroke. Whereas during first half, that is when the crank travels from IDC to ODC, or piston travels from left to right, there will never be water discharge, and that itself will reduce the efficiency of the single acting reciprocating pump to 50%. Of course, but as there are no leakages, through the piston cylinder mechanism, there will be high pressure generated, but discharge will always be low quantity of water or low quantity of liquid will be discharged, as only one half of the rotation of the crank is utilized for discharging the water or delivering the water. So that is the major disadvantages of this pump. So if you do not require continuous supply of the water, and if you require higher head, and if it is permitted that lower discharge is allowed, then you can use this single acting reciprocating pump.